Hello, my name is Joshua Keith, and this is Newton's second law of motion. My unique problem required calculating the acceleration of a cart when two different forces acted on it. This directly ties to Newton's second law. Earlier parts of the project talked about how force, mass, and acceleration relate, but usually through examples and explanations. My new problem goes further by requiring actual numerical solving, not just identifying terms or choosing an answer. The problem connects because it uses real numbers for mass and force, requires calculation, net force, requires solving for acceleration, showing Newton's second law in action, and shows how changing one variable, like force or mass, changes the motion, just like earlier demonstrations in this project. This problem is not complicated or multiple choice, or conceptual or multiple choice. You must do real math to find the final acceleration, proving how Newton's second law applies to real physics and motion. Some benefits of my problem. Working through my problem helps someone actually see how force and mass affects the way something speeds up. It turns Newton's second law from just a formula into something that makes sense in real time. By solving it, a person gets to practice with things like figuring out net force and plugging numbers into real equations. Once you can handle these types of problems, you can move on to others, like forces that change while something is moving, problems that involve friction and or tension. Development of a problem. I made the problem from scratch by picking simple, realistic setups with a cart with differential forces on it, so it actually uses Newton's second law in a meaningful way. It isn't too easy because you still have to find the net force and solve the acceleration, not just plug in random numbers. It isn't too hard either, since it only uses the basic formula and stays away from extras like friction and angles. Uniqueness of this problem. Textbooks and online problems usually are super basic. They give one force and one mass. Mine uses multiple forces, and so you actually have to figure out the net force. I added small details like directions and realistic numbers, so it feels more like something you'd see in a lab instead of a copy and paste example. This is a visual for my problem. This is my data chart. This data shows a chart responds to increasing force when applied while mass stays the same. These are some formulas, variables, the constant, there is none. In the formula, A equals mF1 plus F2. The solution for my problem, a 5 kilogram cart is being pushed by two forces, 20 newtons in and 10 newtons, both in the same direction. What's the acceleration of the cart? Mass, M equals 5, force, Fm equals 120, F2 equals 10, unknown acceleration. The answer, the cart accelerates at 6 milliseconds in the direction of that it was pushed. Verification of the problems, again we got 6. Is this answer reasonable? Mass, 5 kilograms is moderate. Total force, 30 newtons, is not too large or too small for this mass. And that's it.